All right, this is the 9 practice test. So first thing, we have this graph over here to the domain and range. So remember, the domain is your x values, the range is your y values. So this one, again, we talked about this in class. I know it looks like it's going to start just to where it goes straight up and down, but it never goes straight up and down. It always slightly goes to the left still. So as it, in my x direction, in this direction, it will continue on forever, never, never, never to the left. So my domain is a couple of ways. Also, it does that on this right-hand side. It slowly goes, it goes really slowly, but it slowly will go to infinity in both directions. So one way you can put it is all real numbers, or you can literally spell all real numbers. It's fine. Or the other way, we said you could go from negative infinity is less than or equal to x is less than or equal to positive infinity. That would work. And the other way you could do it, the same way we just learned in section 9.6, with the brackets and the parentheses, you could say negative infinity, comma, infinity with parentheses. All those will work for your domain. Doesn't make any difference. Honestly, the easiest one or the quickest one is to put that all real numbers. Now, your range is kind of the same thing. I think it's a little bit more obvious with the range that it goes to infinity this way. But if you notice, this is the lowest point it goes. It doesn't go anything below that. So again, a couple ways you can write it. One way you can write it is that your y, because again, your range is your y's, is greater than or equal to, that is negative 9. My answer can't put positive 9. I'm going to have to change that. So that is negative 9, obviously. You could also do negative 9 is less than or equal to y is less than or equal to positive infinity. Just saying that your graph is in between negative 9 and infinity. Or again, the other way you could put it is negative 9, comma, infinity, parenthesis. Either way will work for me. I'm not super finicky. It all kind of means the same thing. But it is negative 9, not positive 9, like for whatever reason I put on my answer key, which I should change real quick. Now the next one says, so again, when we're talking about increasing and decreasing, we're talking about if we're going from the left to right. So let me zoom in real close on this one. Maybe that'll help. Oops. Oh, from left to right, the same way we would read a book. It is going from here, we start up, and it's going down, 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 it's going down, it's decreasing until here, and then all of a sudden right there, it turns around, and now it starts coming up, so now it's increasing here. Well, then it gets to this high point, then it stops, turns around, starts decreasing again, until it gets to that low point, and all of a sudden it turns around and starts increasing again. So where is it increasing? Between here and here, it's increasing, and between here and infinity, it's increasing. So, don't need to be that close. So, 1.7, 1.7, and this is apparently negative 0.2, and this is positive 1.7. So those are the points they're using for this. So everything less than negative 0.7 is over here. That we said was decreasing. I put that in red, so that's not increasing. Between negative 1.7 and negative 0.2, it is increasing. That's that blue part I just talked about. Negative 0.7 positive, so that's the next part's another red part. Then again, it comes back up, everything greater than 1.7. So that's when we talk about increasing or decreasing, and that's what we were talking about. Now we're going to look at this other graph. So one thing I will say, a lot of people for the domain on this one on the quiz, they did their ordered pairs. So they said -4, -2, 2, and 7. Now, I get where you're coming from, but you also have to realize, what about all the x's in here? All the x's in here are also on the function. So if your function didn't have those dots that were connected like that, or if these black lines weren't here, it was just this big dot, this dot, this dot, and this dot, then you'd be fine. But since they connect them, you need to have all those in between those as well. So again, just like we talked about in the last one. A couple different ways you can look at this. So your domain goes from this one over to this to 7. So you could say it is in between -4 and 7, which is -4 less or equal to x is less or equal to 7. Remember, you always have your lowest number on the left, your highest number on the right, and your inequalities always both point to the left like that. Or again, you could do it like we did in class in the other lesson, -4, 7. Either one is the same thing, doesn't make any difference. Now your range is the y values. So the y values, the lowest point is right here, the highest point is up here. So again, you could do -3 is less than or equal to y is less than or equal to 2. Or again, same thing, you could say -3, comma 2, and make sure they're brackets because they are equal to for that one. That bracket doesn't look great. There we go. Minimum and maximum. Every time we have the minimum and maximum, we're talking about the y values. So the maximum is the highest it goes, which is 2. The minimum is the lowest it goes, is -3. And that should be very similar to your range. Just make sure you're being careful with that. G of -4. So remember, that means you go to -4, because this is my G equation, my G function. Go to -4, and then you go up or down until you hit your function. When you do, how much did you go up or down? So this one, you go down. So you hit that. That's right there. We went down 2. So -2. G of 2 goes up. So we hit it right here. That is at 2. Where are the zeros? That is just where it crosses your x-axis. So we have one at -3 and one at 4. There's only 2 places it crosses there. And just like the last one, except for now we're not circling, where is it increasing, where is it decreasing? Again, we're going left to right. So right here, it is increasing as you go from left to right. And then over here, it is decreasing. So what are those intervals? So -4 is less than or equal to x is less than or equal to -2. And these are both always x. So make sure you're keeping track of that. Again, the other way you could have done, -4, comma, -2 with brackets. Then the decreasing is from 2, less or equal to y is less or equal to 7. That is 2, comma 7. Now, we're not using that graph anymore. This one says, what are the excluded values? So you don't actually have to solve this the whole way. You just need the excluded values. So to do that, really all you need to do is factor the denominator. I'm going to factor both of them just because I want to make sure we're on the same page with that. So if you need to actually do all the work and say factors of -10, that ought to be -3. The factors of -10 are -1 and 10, -2 and 5. That adds up to be +3, so I need to change my signs. So that's 2, -5, x plus 2, x minus 5. If you still need to do that, that's fine. You just don't have to do that. And you can do it obviously differently. Sometimes you can do it, sometimes it's harder, so you don't have to, whatever you need to do. I guess that's probably backwards. If it's harder, you might have to do it. If it's easier, you can skip it. Either way, you don't have to do it, so whatever works. And then again, same thing, factors of 8 that add up to be 6. Factors are 8, 1 and 8, 2 and 4. It's got to be 2 and 4. So we have x plus 2, x plus 4. So again, we really didn't need the numerator on this one. All we needed was the denominator, because that's the part that our excluded values come from. Your x cannot be equal to, what would make that 0? -2. What would make this 0? -4. Because again, if you plug those in, it gives you 0 in the denominator, and you can't have that. So really, we didn't have to worry about the numerator in this one. We only had to worry about the denominator. Now, I will say, if they do ask you to simplify this or, simplify this or divide, we would cancel those out, and it would just be these 2 left. But we don't have to do any of that. All we need is those 2 excluded values. Later, we'll talk about the reducing. Now, one thing before I even sketch this, I think was helpful along, and I put these little points on here, so I knew those nice grid points. I knew where those were at. And the other thing is, remember, you reflect it across the line y is equal to x. So that's something like that. So actually, I think it's earlier. Let's zoom in on this guy real good so we can actually see what's happening. So remember this one, and maybe I should have done a little less confusing. We're seeing how far we are away from that diagonal because we have to do the same distance on the other side. So this one is 1 step, 2 steps away. So we go 1 step, 2 steps away on the other side. So that's that point. Sorry, I was trying to clean this up so it doesn't get too confusing. Not working super well. This one is a half step away, so we go a half step away over here. As many of these as you want to do, we have this one's 1, 2.5, so we have 1.5, then 1, 2. The other way you could do it is once you know that, hopefully you can see the slope of this other line is going to be -2/1. So I can just go down 2/1, down 2/1. Either way you want to look at it, I don't care. You can either reflect it, or again, remember, you could say this ordered pair is over 6 down 1, so I need another ordered pair at -1, 6. -1 up 6 would be way up here. So you could do it that way as well, where you find some ordered pairs and flip those. But ultimately, one thing that can make this easier is if it's a line, the inverse of a line has to also be a line. So once you have 2 points on this, so we're 1, 2, so we're 1, 2. Once you have 2 points, if you just connect those, that's your line. So really, hopefully, you don't have too much to do with that one. Let's zoom back out here. Now the next one, approximate the correlation coefficient. That is R is equal to. Obviously, it's a pretty strong correlation. They're not like all over the place, and it is positive, so I know my R is going to be positive. This one I would say like maybe 0.9 or 0.8. Now again, you're estimating, so as long as it's semi-reasonable, but on the test, it will be multiple choice, so you don't have to worry. I mean, again, it is an estimation, but hopefully I'm going to put some on there that if you actually know what you're talking about, there's some that are obviously not true. Like for instance, if I said one of the options is R is equal to -0.9. Well, obviously this is not negative, it's positive, so that can't be our answer. Sometimes I put R is equal to 1. Or remember, if it's 1 or -1, that's when these dots are in a straight line. Those are obviously not in a straight line. They are all over the place. They're close, but they're all over the place. So obviously that's not your answer. Or R is equal to 0. Well, there is somewhat of a correlation here, so obviously that's not going to be it. So again, I do that with multiple choice, and you can rule out some of them that are obvious ones. Which of the following are functions? This one is not a function. See how that branch goes in 2 different directions for number 1? It goes to an A and to a B, so no, that is not a function. This is the vertical line test. There's no points that cross twice, so that one is a function. This one, the x don't repeat at all, so this one also is a function. But the last one, we have this 2 that repeats. And again, we don't care about the y values. Like over here, this y value repeated, we don't care about that. We only look at the x values. Since the 2 repeats, no, this one's not a function. Your x and your y. Sorry, I don't want to run out of room here. So you switch x and y, and then you solve for your x. So add 5. X plus 5 is equal to 1/4 y. Sorry, I messed that. I mean, I said the right thing, did the wrong thing. There should be a y there. Then to cancel out that 1/4, I multiply both sides by 4. Make sure you distribute that. So it is 4x plus 20. That is y. But again, I like to take the extra step and say my inverse of f is 4x plus 20. Did that one wrong on the answer key as well. Hopefully I can get that taken care of. So the other thing, we have x squared. The other one, same type of thing. Just make sure you put your y in there. And then switch your x and y. Now again, that you can do all in one step. I don't care. That's what I would probably do. but just the people that are a little bit confused, I like to go ahead and put that other step in with the x and the y. So from here we add 15. Of x plus 15 is equal to y squared. To get rid of that squared, I have to take the square root. So I end up getting plus or minus x plus 15 is equal to y. Almost said y squared. But then that is the inverse of your g of x. So that is plus or minus the square root of x plus 15. Again, try not to forget that plus or minus. We do that because we canceled out that square. Next one, we are evaluating this piecewise function. Remember, we just can only use these functions, and if it helps you to put y's equal to in each of these, you can. But you're using each one of those functions depending on if it falls under these circumstances. So -5 is less than -3, so this is where you plug in your -5. So 2 times -5 plus 1 is -10 plus 1 is -9. The other one is 4. Well, 4 falls into the category that's bigger than 2. Well, the good news is if you plug 4 in, you just get 4, since it's just an x. Then 2 is a little bit tricky. You have to be careful with 2 because 2 has 2 spots that you might think they could go, this one or this one. Well, it's important to remember, since this doesn't have that equal to sign with it, this is only saying x is greater than 2, and 2 is not greater than 2. It's equal to it. That's why we have to do this one, because it's got that equal to mark. But that's good. This one should be easy. That's just 5. And last but not least, f of 0. Again, that falls into this category between -3 and 2, so that is just 5. Remember, we don't multiply anything. If it just says 5, that means no matter what your input is, your output's always 5. I could plug in 1,000, it's still going to be 5. Okay, next one is over best fit lines. It says Larry's getting better and better fishing every year. He started collecting data on how many fish he caught per year starting in 2010. He put all his data into a graph using 2010 as 0. He found the best fit line to be, and this is the equation, and then they tell you f is equal to y is equal to blah, blah, blah. Using the best fit line, predict how many fish you will catch in 2030. Well, the first thing you have to realize is the number you're plugging into this is not 2030. It is how many years since 2010? How many years since he started collecting? So that is 20. So take that 20, plug that in. That's 20 years. That's why you plug it into y. Plus 8, which is 68 fish. Approximately. Again, that's just a prediction with the best fit line. He could catch more, he could catch less, but if his trend continues, that's approximately how many fish he'll catch. Technically, I should label it fish, but not super nitpicky on that yet. There are 2 different ways to do this. I think the easiest way is take one of them, doesn't matter which one, this one, and find the inverse. So that is x is equal to 2 over 3y plus 6. Again, I switch the x and y in that first step. Then when we solve this, I subtract 6, that's x minus 6 is equal to 2 over 3y. Then multiply by, you could multiply by 3 over 2, the reciprocal. I like to do one step at a time, so I would multiply by 3. And then I divide by 2. That gives you 3 over 2x minus 9. Now, to explain why or not, all you need to do is we just found the inverse of d of x. So the inverse of d of x is equal to c of x. So they are inverses. Because the inverse of d of x is equal to c of x, so it means they are inverses. So that's the way I would do it. That's the first way. The other way you could do it is using composition. The only downside to that one, besides that composition is new, is that you have to do it twice. So if you use the composition method, I need to do d of c of x and c of d of x. So we plug c into this equation. So I have 2 over 3 times 3 over 2x minus 9. Don't forget that we still have a plus 6. So when you multiply numerator and denominator, you get 6 over 6, which is 1. And then 2 times 8, and again, I would use a calculator if I were you for this stuff. But that is 2 times 9 is 18. 3. It's supposed to be plus 9 equal to. Sorry, tired. It's catching up with me. But 6 over 6 is 1. 18 over 3 is 6. So that ends up just being x, which is what we want. But now we have to do the same thing to the other one. So now I plug d in for this x, so 3 over 2 times 2 over 3x plus 6. Minus 9, don't forget about that. Again, when you multiply this out, you get 6 over 6x plus 18 over 2 minus 9. So that cancels. 18 over 2 is 9. So 9 minus 9. Sorry, we should say, yeah. No. Sorry, there is no equal to sign. Sorry. Whew. Those cancel out, so we just have x, so it worked for both of them. So to explain, I'd say they are inverses, and for y, I would simply put b of c of x is equal to x, and c of d of x is equal to x. But again, I like the first method better. I think it's a little less, more math that we're actually used to doing. Graphing a piecewise function. Now again, it's important to realize that they're just telling you where each one of these parts go. So -1 is right here. I'll use this light yellow. -1. And +2 is right here. So again, they're really just saying this equation goes here on the left-hand side of that. This equation goes in the middle. Equation goes at the end. So we just graph those in those 3 different spots. The good news is this first one is a horizontal line. There's no x or anything with it, so it's just a horizontal line of 2, and it is filled in. So it's got the equal to part. Slope-intercept form, so -1 is right here, and you go up 1 over 2. Whoops. I shouldn't have drawn that past those yellow lines. That was close. And one of them's open, this one, and this one's filled in. And last but not least, your x, your y-intercept would be 0, and then you go up 1 over 1. So normally it would be like this, but again, you can't do anything in between those 2 yellow lines. So that means it just goes from here, and it's an open circle. All right, piecewise function when you are dealt with a graph. -1 is right here. Again, just like we did earlier, I go up to 3. 0, it's not this one because it's open. It's got to go to the solid one, so that's down 1. And the next one, 3, is up to 2. I should have changed your domain and range for this one because it's not super exciting. See this way? So it starts here and goes over here. This point would be filled in, so it goes to here. That's your domain. Again, however you want to show it, the way we did it in class. So that's how we did the first time. You could also say -4 less than or equal to x is less than or equal to 3. And your domain is the opposite. This is the lowest it goes. There's no jumps, there's no gaps all the way to here. So your range is here up to here, so -3 to 2. So again, -3 less than or equal to y. Make sure you put the y there, 2. I randomly put a bracket on this one and shouldn't have. Okay, and that brings us to the left page, which is the one with the function bank. I will say on the quiz, this is where a lot of people made mistakes, and it's just mainly because they didn't set it up right, so then they couldn't solve it right. Okay, so g of -5 means plug -5 into that equation. Just remember, again, every time a mistake, a lot of people said -25. -5 squared is -25, and it's got to be positive. So 25 minus 16 is 9. This one we're subtracting, so my h equation, 5x minus 4, subtracted by my f equation, 2x plus 3. You have to distribute that negative. That's another very common thing that people missed on the quiz. Oops. Long day, short night. Don't really need the parentheses when you do that distribution. So 5x minus 2 is 3x. -4 minus 3 is -7. So that should have been your answer for that one. I'm going to have to scroll down so I can't see the function bank anymore, but hopefully you guys can still see it. So this one's f times g, so it's just 2x plus 3 multiplied by x squared minus 16. 2x times x squared is 2x to the third. 2x times 16 is -32x plus 3x squared. And 3 times -16 is -48, I believe. Now you could leave it like that. I usually go in order from my highest exponent to my lowest exponent, so most of the time I will rewrite my answer. Where did we go here? Oh, I didn't know I got 16 up there, not 2. So that is a 3x squared minus 3x, 32x minus 48. The next one is one's a little bit more difficult, and I will say the excluded values, if you put them on here, I give you actually extra credit for it. But your j is x plus 6. Your m is x squared plus 3x minus 18. If that's all you put, I gave you half a point, but that's just setting it up. We need to simplify this. So we need to reduce the denominator, factors of -18, to add up to be +3. That is x, excuse me, x plus 6 times x minus 3, and the x plus 6 is canceled. Now, one thing, if your numerator all cancels, you need to put a 1 in there. A lot of people miss this on the test because they just put x plus 3, and it's got to be 1 over x minus 3. Sorry, I messed that up almost. Excluded values for this one, if you remember those, are anything that makes this 0. So we have x cannot equal -6 and +3. Moving right along. The next one, 6 times m of x. You just take 6 and multiply by that. So 6 times x squared plus 3x minus 18. That's 6x squared plus 18x minus 18 times 6 is 72, question mark? No, not close, 108. I think I found another mistake in my homework. I took 3 times 6 is 16, not 18. So that is what you get for that one. The next one, so that one, I guess really we're trying to practice, or I was getting you to see, that's when it's outside your function. Since it's outside your function, you can multiply by the whole thing. If it's inside your function, you need to put that into the x of your other equation. so g. So it's going to be x plus 5 squared minus 16. Then simplify this out. We have x plus 5, x plus 5 minus 16. So that's x squared plus 5x plus 25 plus 16. I know that's sloppy. I really want to get that in this class period. Now I have 10 minutes left. So we can combine our like terms. I know you can't read it super well, but those are both 5s. So we have 10x and then 25 and 4. No, 16. I didn't think that sounded right. 25 and 16 is what? 41, I want to say. Oh, it's minus 16. Jeez. I had it up here. I just wrote a little bit too small. 20, and I'll make that look more like a 16, not a 4. 25 minus 16 is positive 9. Now, the next ones are compositions, and I wrote them like this to help you guys out. So I'm putting g of x into the x equation. So the x equation is 2x plus 3. But now I'm taking out that x, and I'm putting in my g equation is x squared minus 16. So distribute that out, 2x squared minus 32. So 2x squared minus 29. The next one, self. So again, you have 5x minus 4. And I'm taking out that x, and I'm plugging it in. 5x minus 4. So distribute that out. That is 25x minus 20 minus 4. It's minus 24. Perfect. This way, you plug the 3, the negative 3 into the g, and then you plug that into the j. Put anything like that for plus. Good. 16. So it's negative 3 squared minus 16, which is 9 minus 16, which is also 9 minus 16. So that's great, but then now that negative 7, that's the g of negative 3, but now I have to plug that into the j. So now it's g of negative 7. This is the only time we do that. If we were adding or subtracting or even multiplying, we don't do it that way. We'd plug it into both of the equations. This is the only one that the one affects another, so make sure you keep that in mind. People miss that on the quiz as well. So we end up getting negative 7 plus 6. And negative 7 plus 6 is negative 1. So this one ends up being negative 1. All right, the last two, your h. You're looking for the inverse of that one. So we have y is equal to 5x minus 4. Sorry, that should be 4. Sorry, just double checking here. Yep. Oh my goodness. Oh, sorry. Restart. My apologies. You have to switch your x and y first. X is equal to 5y minus 4. Now we can start solving this. So I add 4 first. Sorry. You guys probably all knew that. Thanks for not spoiling it. So we end up getting your h to the negative first of x is 1 over 5x plus 4 over 5. You can't reduce either of those. That's fine. That's just your answer. And the last one is the inverse of g of x. So again, we have y is equal to x squared minus 16, but we need to switch the x and y. So add 16 to both sides. X plus 16 is equal to y squared. To cancel out that squared, we take square root of both sides, which means we need a plus or minus. So we have y is equal to, whoops. So y is equal to, but I'm going to change it to g to the negative first. G to the negative first of x is equal to plus or minus the square root of x plus 16. Make sure you don't reduce that 16 part. I know the square root of 16 is 4, but that does not mean you can do that. That is not a property that actually works. So that's it. Sorry it took so long, and sorry that I was super tired, made some mistakes in there, but hopefully this is helpful. If you have any questions, make sure you let me know.